Hello students, today we are going to start with new chapter, that is basic concepts of chemistry. This is the first chapter we are going to start for this sem. First we will start with IUPAC nomenclature. IUPAC nomenclature is most important part of organic chemistry to determine some properties by their name. So full form of IUPAC is International Union of Pure and Applied Chemistry. We will start with IUPAC nomenclature. Before we name some compounds, we should well known to few rules and regulations. In an organic compound, they mainly constitute carbon and hydrogen, or maybe some few other atoms. In organic compounds, we take carbon as a main element just because it has four properties, that is catenation, covalency, tetravalent and allotropy. Catenation is a property which means elements forms bond with itself to form a long chain, and that can be possible in carbon for infinite numbers. That's why it has high catenation property in all the elements in periodic table. Then covalency. When we are going for formation of a bond, there should be we follow the octet rule. Carbon mutually shares electron to form a bond, that is called covalent bond, and that's why it shows covalency. Whenever carbon will form a bond, that should be mutually shared with other elements. Next one is tetravalency. If we will go through the configuration of carbon, that is 2, 4. So it has 4 valence electrons to share. So that's why it is called tetravalent. Before we start the naming, we have to find out some things, that is parental chain, or we can say that carbon chain. Then we will find the functional group, then we will discuss about bond order, then substituent. Before we name a compound, we should find these 4 things in that compound. First, parental chain. We will find how many carbon atoms present in that compound. Then we will find how many carbons are aligned in a same line, and longest carbon chain. We should find out the longest carbon chain. हमें समझे लॉन्गेस्ट कार्बन चेन को फाइंड आउट करिबा सबुठु लॉन्गेस्ट के हे पाउची. Then we will proceed to functional group. Functional group may be an atom or element or group of atom, that we are saying molecule, which decides the properties of a molecule or members of that compound are called functional group. Then we will consider about the bond order, whether it is a single bond, double bond or triple bond. Then we will discuss about the substituent. In this case, we always prefer least position. In this case, we will always consider the least position. First thing, we have to find out longest carbon chain. Then we will find whether it contains functional group, bond order or substituent. Priority should be given to functional group. If functional group is present, then it should get the least position. According to that, we will position or locate bond order and substituent. If functional group is not present in that compound, then we will proceed to locate the bond order. It will get the least position, then substituent. Always remember, it may be longest, it may get least position, but irrespective of the direction. The naming of compound is irrespective of direction. We can name it or number it from the left to right or right to left. We can name it left to right or right to left or top to bottom, bottom to top. We will start with few names. Initially, when we are going to name the parental carbon chain, we should know what should the suffix are using to name the carbon atoms. If there is one carbon is present, then we will say meth. For 2 carbon, it will be eth. 3 carbon, it will be prop. 4 carbon, it will be but. 5 carbon, it will be pent. 6 carbon, it will be hex. 7 carbon, it will be hept. 8 carbon, it will be oct. 9 carbon, it will be non. 10 carbon, it can be deca or dec. Now, for bond order, when we are discussing about the bond order, what we will use? If it contains single bond, then we will use A and E. If there is a double bond, then we will use E and E. If there is a triple bond, then we will use Y and E. Now we can see during the naming, there is a possibility that these two words will combine. There what will happen? It will end with vowel and it will start with vowel. Always remember, if we are compositing two words where the first word ends with a vowel and second word starts with a vowel, then we will cancel the vowel of first word. Let's see, you can copy it, then we will proceed. Now, we know that carbon has tetravalent property, then I can mention carbon like this. Each hydrogen can form one single bond. Here carbon is forming 4 single bonds. So as this compound contains one carbon, it will be considered as meth, and we can see all are single bonds. That's why it is N. Its name is methane. Similarly, if I am considering about 4 carbons, 1, 2, 3, 4. I told you that carbon has a catenation property. It can form, as long it can form the chain, and it can form only 4 bonds. Now we will see this carbon can form 4 bonds. Out of that, 1 already done. So it remains 3 carbon. So I will write 3. 1, 2. 4 minus 2, 2. So 2 more bonds are required. So I will write CH2. Here I can see also same here, CH2. 4 minus 1, 3. Here I wrote the structure. How many carbons are there? 1, 2, 3, 4. Meth, eth, prop, but. So its name will be but. And all contains single bond. That's why ANE. Now we can see this word end with E, which is a vowel. Again, another word starts with A, that is also vowel. As both are vowels, then the vowel of the first word will be cancelled out. So what will be the name? That the name will be butane. So in this way, we can write out the names. Okay. Now, how to name them in a skeletal form? How many carbon atoms are there? 4 carbons. All are single bonds. 4 minus 1, that is 3. So our line structure will be like this. This is our line structure, that is alkane or butane. Consider I am writing hexane. Hexane means 6 carbons. 6 minus 1, 5. So our line should contain 5 carbons. 5 lines. 1, 2, 3, 4, 5. Now count 1, 2, 3, 4, 5, 6. It contains 6 carbons, 5 lines. It is called hexane. Now consider I am using the multiple bonds. Double bond. 4 minus 2, so it will remain 2. 4 minus 3, it will contain 1. 4 minus 1, 3. Here we can see it has 3 carbons. That means prop. And 1 double bond. That's why it is in. It is propene. Now 3 carbons. 3 minus. So for 3 carbon we can give 3 minus 1, 2 lines, that is like this. 1 contains double bond, so our line structure will be like this. Now consider I am giving you same compound CH3, CH2, CH2, CH, double bond CH2. First of all, we will count how many carbon atoms there. 1, 2, 3, 4, 5. Meth, eth, prop, but, pent. So it is pent. Now, what with the double bond? We will consider ene. So its name is pentane. Now, what should be the line structure? 5 minus 1, 4. 1, 2, 3, 4. At the end, it has a double bond, so we will give the double bond. It is our structure. Now, what about the alkyne? Now consider, I am writing CH3, CH2, CH2, C, triple bond, C, H. So we can see here 3 to 5. 5 carbons are there. That's why it is pent. For triple bond, we will write YNE. So its name is pentyne, and it has, we will do the line structure. 5 minus 1, 4. 1, 2, 3, 4. At the end, it has triple bond. 1 above the line, 1 below the line. These lines shows the presence of pi bond. Okay. Now, we will discuss about what if this bond will be present at here, or this bond will be present at here. Now consider I'm writing CH3 CH2 CH double bond CH CH3. So I told you our first priority is to find longest carbon chain. It is a very simple longest carbon chain. Then the priority is to find out the functional group. There is no functional group or bond order. Yes, I can see the bond order is 2. And third one is substituent. There is no substituent either. Now we will give the least locant or position to the bond order. That is, we will find how many carbons are there first. 1, 2, 3, 4, 5. 5 carbons are there. That's why I am writing pent. And one double bond is there. So I will give the ENE. Before that we will consider to give the position to the bond order. Some may count from the left to right, or other may count from right to left. That is 1, 2, 3, 4, 5. If I am giving it position from left to right, I am getting the double bond at 3 number. So from left to right position, I am getting third position. Now consider about from the right to left. 1, 2, 3, 4, 5. So we will find that second position getting double bond. Now I got from left to right third position and from right to left second position. So out of 2 and 3, 2 is least, so we will consider the second position instead of 3. So our naming will be pent 2ene, pentuene. It means you can locate it from any direction. Out of that, in which direction you are getting the lowest locant value or position value, that you will have to consider. Now we will consider another case. Three, 3, 6. So its name will be X. If I am considering the position from left to right, 1, 2, 3. So I am getting the third position. If I am getting from the right, 1, 2, 3. In both the cases, I am getting the same position. That's why it will be hex 3. For double bond, I am using ENE. Now we will do the skeletal diagram. It has 5 carbon, so 5 minus 1, 4. 1, 2, 3, 4. Sorry, 3. No, 4. 5 minus 1, 4. I have to draw 4 lines. Now I am getting second position double bond. 1, 2. So our line will be like this. Here 6 carbons are there. 6 minus 1, 5. So I will draw 5 lines. 1, 2, 3, 4, 5. At third position double bond. 1, 2, 3. Okay. This line can be drawn below the solid line or above the solid line. It's up to us wherever we can draw. Now consider I am taking about 1/3 bond wine product. CH3, CH2, CH2, C triple bond C, CH2, CH3. In this case, I can clearly see it will get the least position from right to left. Still I will count it. 1, 2, 3, 4. I got the fourth position from left to right. Similarly, if I will count it from the right, I will get 1, 2, 3. I am getting 3 position, which is a least position value. Now I got 5, 6, 7. 7 carbons that I am using hat. At 3 position I am getting triple bond, hat 3 wine. For 7 carbon, 7 minus 1, 6. So I have to draw 6 lines. Then at 3 position, triple bond. 1, 2, 3. This is our skeletal diagram.